Hello again, art and data enthusiasts. Welcome back to my channel where we explore the beautiful intersection of art and data science. Today, we are starting to investigate the world of data science. Whether you are a beginner or just curious, this video is for you. Before I dive into the technicalities, let me share a bit about my own journey with data science. My data science journey began in 2006 during my PhD. I delved into multivariate analysis and chemometrics. It was my first taste of the vast world of data. While I always stayed connected to the field, it was only a year ago that I truly intensified my focus on data science. The drive, it was a need to publish articles and keep up with the rapid advancements in the field. This led me to explore new algorithms and techniques. To document and share my knowledge, I started a blog. And recently, I stumbled upon ChatGPT and its code editor plugin. It's fascinating how it opens up new possibilities in the realm of data science. This journey often makes me wonder, what's the real value of investing time and effort into data science? And where does the future of data science lie? In this introductory video, I will cover key aspects of data science. The common terms such as artificial intelligence, machine learning, deep learning, and chemometrics will be explained and differentiated. Next, the data sources or where to obtain the data for practicing data science will be mentioned. I will also mention the learning resources which are used for mastering data science. Next, the popular programming languages that one needs to practice data science will be stated together with my preferred IDE for data science. Lastly, I will touch on ChatGPT and the future of data scientists with it. Data science is an interdisciplinary field that combines math, statistics, programming, and subject matter expertise to extract insights from data. Through mining, cleaning, visualizing, and even using machine learning magic, it paints a clear picture from our data. In essence, data science is our modern day compass which guides us through a sea of information. A subject matter expert would provide critical insights into how data should be interpreted, which features might be relevant for particular analysis. If 30 genes are selected as important for differentiating cancerous samples, an oncologist might be able to fine-tune a smaller subset for therapeutic or diagnostic purposes. Let's delve into the realm of artificial intelligence. Imagine machines that don't just compute but can also think and interact like us, mastering skills, solving challenges, and actively engaging with their surroundings. That's the essence of AI, a blend of research and innovation to make machines more human-like in their intelligence. Some of the things that leverage AI are smart assistants like Amazon's Alexa, Google Translate, and autonomous vehicles or self-driving cars. Machine learning can be thought as the brain of artificial intelligence systems that focuses on teaching computers or machines how to learn from data, without being explicitly programmed for specific tasks. Machine learning involves the use of statistical methods and algorithms to train models that can make classifications, predictions, and uncover insights in the data. Deep learning and neural networks are related subfields of machine learning and artificial intelligence. Neural networks are a type of machine learning, and deep learning is a specific kind of neural network. Both these neural networks can be related to how biological neurons send signals and process them. A neural network consists of an input layer, an output layer of neurons, and one more hidden layers in between. Deep learning typically employs more than 4 hidden layers of neurons for complex learning tasks. Some examples of deep learning architectures are convolutional neural networks, which are used primarily for image analysis, and another is recurrent neural networks. These are suitable for sequential data like time series or natural language. A feed-forward neural network or multi-layer perceptron with 5 input neurons, 3 output neurons, as well as 2 hidden layers of neurons is shown in the figure. Classical or non-deep machine learning relies heavily on human intervention to learn and is suited for structured data. Examples of structured data are like Excel sheets that are used to organize data or information. Typically, rows are used to represent samples or individual observations, and columns represent features or independent parameters. Human decision on number of independent parameters to be used for training in machine learning models and the same number be used for prediction is necessary. Unstructured data such as text document, images or videos may not be as effectively handled by classical machine learning algorithms. The number of words in a document, the size of image, and the length of videos need not be fixed, and deep learning can make better sense of such data. Chemometrics is a discipline at the intersection of chemistry, statistics, and data analysis. It uses sophisticated math and statistics to decode intricate chemical data, turning vast amounts of information into clear, insightful discoveries. Deep learning is part of machine learning, and both are subsets of data science. When any of them are used to study chemical information, they are considered as chemometrics. AI is the broader field that encompasses all. In data science, obtaining the right data is crucial. In fact, sourcing relevant and high-quality data is a foundation step. One way is to generate your own data through experiments, like what I do for my students using FTR spectra. Another option is to use publicly available data repositories. My favorite data repositories are Kaggle, UCI Machine Learning Repository, and Gene Expression Omnibus or Geo datasets. Kaggle has the largest artificial intelligence and machine learning community with over 14 million machine learning enthusiasts and 244,000 datasets. Other than datasets, Kaggle provides resources such as notebooks, discussion forums, free courses, and competitions. Kaggle notebooks provide an interactive platform to write, execute, and share code. Users can create Jupyter notebooks with Python or R, allowing for data exploration, visualization, and model development. Kaggle is renowned for its machine learning competitions, where participants compete to create the best predictive models for specific tasks. These competitions cover diverse topics and offer real-world challenges to solve. The UCI Machine Learning Repository, maintained by University of California, Irvine, is a widely used online collection of datasets. It serves as a valuable resource for testing and evaluating various machine learning algorithms and techniques. The repository contains a diverse range of datasets covering a wide subject area such as life sciences, business, etc. Each dataset is accompanied by a description of its attributes, its number of instances or observations, and whether the data is suited for classification, regression, or clustering. The gene expression omnibus geodatasets can be accessed through the shown URL. The dataset is hosted by the National Center for Biotechnology Information, or NCBI, which is part of the United States National Library of Medicine. Geo provides a valuable platform for studying various aspects of gene expression, such as identifying gene expression patterns in different tissues under different conditions and in response to different treatments or interventions. One limitation of these data sets is the number of samples could be small in them. Despite this, various multivariate studies in scientific literature have used this data. My favorite resources for learning data science are Udemy courses and the videos in YouTube. Here, I am just showing a snapshot of the courses I am subscribed to, and my blog shows a longer list of my favorite courses as well as the videos I like in YouTube. A YouTube channel which I've learned a lot is that of Chris Knight. Code Basics videos are also engaging and informative. This is a specific channel that I refer to for image analysis. Edureka is another channel that has vast information. The trick in using all these videos are to look for relevant information and to stop once you have found at most 2 videos. Although I started data science with R programming language, I would say it is better to start with Python due to its extensive ecosystem of libraries such as NumPy, Pandas, scikit-learn, TensorFlow, and PyTorch. The second choice would be R. Java might not be as commonly associated with data science as languages like Python or R, but it still has its place in the data science ecosystem and can be used effectively in certain contexts, such as those that involve big data processing, integration, and building custom applications. Alternately, one could pick up Python and SQL. SQL, or Structured Query Language, is a specialized language for interacting with databases, enabling users to create, modify, and retrieve data efficiently. Although text editors like Notepad++ can indeed be used to learn Python, when it comes to data science, Jupyter Notebook provides an immersive and interactive learning experience. As one's coding skills advance and the projects become more complex, transitioning to a traditional integrated development environment or IDE is better. The IDE can equip the data scientists with a powerful suite of tools for efficient coding, debugging, version control, and software development. Common Python IDEs include PyCharm, Visual Studio Code, and Spider. PyCharm, developed by JetBrains, is widely used and is feature-rich and is also my favorite. It has intelligent code completion, a powerful debugger, version control integration, database tools, and support for web development frameworks like Django and Flask. The running of Jupyter Notebook for image analysis is shown. It needs a large set of images, often numbering thousands for training. As a result, the analysis requires high computation power and memory resources. A problem often faced is overfitting, where the model learns the training data too well and fares badly on new unseen images. The computation matrix for a new set of 5 classes of different flowers is showing predictability only slightly better than random guesses. Of course, the use of transfer learning significantly improves the results. Luckily, spectral data and gene profile analysis produce better classification results. However, new tools such as ChatGPT would improve or facilitate faster analysis. My suggested use of ChatGPT Plus in data science. The first is data analysis. Simple data analysis. Example, finding average missing values or confirming the number of observations, number of independent parameters, etc. Instructions can be given in a conversational manner, and the answer is almost instantaneous as shown in the snapshot from ChatGPT. Data visualization. It enables plots or graphs to be displayed as shown. And the third is code generation and execution for simple algorithms. Factors to consider in the use of ChatGPT. The development of problem-solving skills and ability to work independently is important for data scientists. Immediate assistance by ChatGPT will hinder this, especially for beginners. The use of real data and preferably not ChatGPT generated data. Often, synthetic datasets are generated with random values and might not mirror the real-life situation. Lack of real-world experience. Beginners who learn data science the easy way might not be ready for the challenges of real-world machine learning projects such as data inconsistencies, computation limitations, or deployment issues. What is the future outlook for data science? Rapid growth with advanced tools. Data science will experience accelerated growth driven by tools like ChatGPT, streamlining the exploration and implementation processes. Methods like genetic algorithms, reinforcement learning, and graph neural network will find increased usage in AI and data science. The shift from memorization to understanding. As tools simplify coding, the emphasis will move from code memorization to a deeper comprehension of underlying algorithms. Holistic skill development. The role of data professional will expand beyond model creation to encompass deployment, monitoring, and ensuring real-world applicability. This demands a higher skill level. The remuneration for starting data scientists might decrease, but those with these skills will be in demand. Importance of reliable data and expertise. The value of dependable data sources and domain expertise will become paramount in ensuring the effectiveness and relevance of data science projects. This will also ensure the generation of such data libraries, for example, image libraries of important herbal samples, disease tissue samples, etc. In short, the future for data science looks bright with more advanced tools. A more complete list of Udemy courses I took, the YouTube videos I've seen, and books I have found helpful is listed in the resources section of my blog. The QR code for it is shown here.